So again, this session will be an introduction to artificial intelligence and machine learning. So basically, this will be also a part of the module, one of the courses for the Open RAN Academy, which is Introduction to Artificial Intelligence. So let me give you what is the expected outcomes for this session, for this lecture. First, we understand what is artificial intelligence. Second is identify different AI-driven applications. But definitely, I believe you've already, of course, some of these applications were shown during the video before this session. Third is to identify the different branches of artificial intelligence, those the general branches, and understand what is machine learning. So we'll try to cover one specific branch, which is machine learning, and differentiate the general types of machine learning algorithms or the learning models that basically, use to develop these predictions or sometimes prescription for different applications. And finally, we understand what is machine learning workflow process, and to further, understand the workflow, we'll try to use a specific use case. Okay. AI is, of course, a simulation of intelligent human behavior. So a computer system or designed to perceive its environment, understand its behavior, and take action. So I think it's common nowadays to interpret AI as something that is trying to imitate the human intelligence or the human behavior. Now, a very good example would be the self-driving car. So we all know Elon Musk, ano. Actually, napanood nyo naman earlier in the video, no? The godfather of AI already resigned, Google. But aside from the godfather, Elon Musk and Wozniak, which is a co-founder of Apple, has also published or like nagbigay na rin sila ng ng kani-kanilang sentiments when it comes to pausing AI. So I think lahat naman merong like limitations. Okay. Now, in the case of self-driving cars, of course, we all know Elon Musk is very popular on this one. But AI-driven systems like these integrate AI algorithms such as machine learning, which we will focus later on, and another branch of AI, which is deep learning, into complex environment that enable automation. So that's the thing here. We want to automate the system. We want to make like manual process to become more like easier by automating it using an approach wherein you imitate the human intelligence. So that actually lessens the influence of human behavior, the actual human behavior, because you are trying to build a model that actually imitates what the human mind can do. Now, they say that in 2030, the AI is estimated to create 13 trillion US dollars of economic value. And we are actually seeing this right now. A lot of the applications, mobile applications, from your banking, from the use of your browser, even your social media platforms, all of them are using AI. Yesterday when I'm watching Philippine news, there was this Boodle app daw. It's a travel Boodle app wherein it uses the Chat GPT to give you recommendations depending on your budget on what areas to visit in the Philippines. So, 'di ba napakadali na nun guys, hindi na siya tulad before that kunyari may budget ka, 5,000 pesos. And then you will look for, okay, ano ba yung mag-fit sa akin na flight, ano yung accommodation, transportation, or tourist areas na pwede ko mapuntahan. But right now, in just a single app, you can already see all of these things in just one search. Again, through the use of ChatGPT. And I know every one of you are familiar and with this platform or with this technology, and hopefully it is not being used for, especially yung mga estudyante, no, in writing their research or writing their school requirements. Right now, that's because AI is transforming engineering in nearly every industry and application area. So again, even in the industry nowadays, AI is already being utilized, especially to improve their automation. But of course, not only the process itself, but it can also be applied to like some fault diagnostics or preventive maintenance. AI is already being directly related also with the technology called digital twin and Internet of Things. So all of these, when you combine, of course, create a complex mechanism that can greatly benefit the industries and of course a specific application. Even government, diba, are already utilizing AI for their processes. Now, beyond automated driving, AI is also used in models that predict machine failure, indicating when they will require maintenance. Even in the health system, using sensor analytics for patient monitoring. So there are a lot of health monitoring app. Actually, that will be our use case later on, and robotic systems that learn and improve directly from experience. So even yung mga robo machine that cleans your house, those are also driven by AI. Now, the definition was actually coined in 1950 and is the capability of machine to imitate intelligent human behavior, as we mentioned earlier. Now, it gets more interesting when machine cannot just imitate, but even exceed human performance. And I believe this might also be the, what do you call this? The reason why the godfather of AI resigned, and also some of the prominent people in the world of AI. Because as I've mentioned nga, kapag sobra, medyo masama rin po, okay? So, if AI, it's possible, that the AI will exceed the human performance. But we always have to consider the ethical factor that might influence these things, and I believe after this session the AI ethics will be discussed also. So maganda yung natin, guys, maganda yung ating lineup for today. Now, it gives us the opportunity to offload repetitive tasks and even to get computers to do jobs more safely and efficiently than we can. So I think that's the advantage of using AI. There's a less human error, especially kapag yung system that we are trying to automate is something repetitive, diba? It's really helpful. Also, yung human emotions kasi, yung human like yung pagod, 'di ba? Hindi anymore, it's not, it's not anymore a factor to consider, when you automate a system. So it's really advantageous. Now, practically speaking, when people think of AI today, they almost always mean machine learning. Okay? So parang there is already like this connotation that, okay, AI is machine learning, but actually it's not. Later on, we will understand that there's actually a huge branch of these AI algorithms. And again, we'll focus for today on this one main branch, which is machine learning. But aside from that, aside from machine learning, there's also like uh, other branches. Okay? So just to give you a brief um backgrounder on the different applications of AI. Of course, we have robotics and autonomous systems. Again, this is the main application of AI to automate systems. But nowadays, depending on the need, so the systems now are being more adaptive. Okay? Unlike before na reactive yung mga systems natin, meaning we simply, like rule-based. It means we simply put instructions dun sa ating system, like a normal or traditional programming. Okay? But in AI kasi, it is more adaptive and proactive in nature. Of course, using using data. Okay? Most of the time, this data are historical, and we are looking at the trend of that data to actually build a model that will be used by the computers in terms of instruction. So it's not anymore the rule-based system or the traditional programming, which is reactive, but it is more proactive. Okay. So of course, from robotics, we have industrial automation, preventive maintenance, patient monitoring, electricity use forecasting, and automated driving. So these are just some of the many, many applications of AI. Of course, hindi tayo matatapos here, kung iisa-isahin natin yan. But definitely, I know you are at least experienced one of or two of these AI-driven applications in your everyday life. Now, let's try to look at the main branches of artificial intelligence. As I've mentioned, one of them is machine learning, which we will be covering today. And aside from machine learning, there's one specific sub-branch of it, which is deep learning. Okay, so deep learning is where neural networks fall. So most of the advanced artificial intelligence fall under this category or branch. Okay, so for this session, we will not cover the deep learning algorithms yet, but further later on, for advanced Aora courses, we might be including these because ChatGPT is part of this one. Okay, so today we'll only be focusing on the general one, which is machine learning. Now, before we proceed with defining what is machine learning, let's try to differentiate first these two. So as I mentioned earlier, in traditional programming, you write a program that processes data to produce a desired output. So mainly it's like a rule based that, okay, I have this output requirement. So this will be the corresponding input. So as simple as that. But when it comes to machine learning, the steps are reversed actually. So you feed in the data and the desired output, and the computer writes you the program. Okay? So for those who are programmers here, of course, machine learning is actually a good approach. It's not that parang tinuturuan niya tayong maging incompetent when it comes to programming skill, but it's actually a good thing to let the tool build the program for you, right? By simply identifying only what is your desired output and what is the specific input features you need to build that particular role or program, 'di ba? Or model, okay? Now, machine learning programs or as mentioned, models are largely black boxes. And these black boxes are actually generated using various types of learning models. Some of them are based on statistics and probability and so on. Now, they can generate the desired output, but they aren't composed of a sequence of operations like, as I mentioned, traditional program or algorithm, which makes it more proactive and adaptive. Because unlike of traditional programs, which very fix yung kanyang mga rules eh. If magbago yung environment, let's say for example, for self-driving cars, wherein there are always changes, dynamic changes in the environment, it is really important that your program can adapt to that dynamic nature. And a traditional program cannot do that. Okay? So that's the advantage of using machine learning. Okay? Um because it's just a black box and its nature depends on what input you feed it. Then it becomes or the box becomes or adjusts to whatever input you fed on it. Okay? So that's the idea. Now, the a more specific branch of it, we call it deep learning. As I've mentioned, neural networks falls under this category. So that deep actually refers to the layers in the network. Okay? So neural network is actually a layer of uh neurals, okay, which actually imitates the neurons of the brain, hence neural networks. So the more layers, the deeper the network. Okay. Now, one key advantage of deep learning is that it removes the need for manual data processing steps and extensive domain knowledge required for other techniques. So very common usage of machine learning is obviously for image classification or image detection. Most of the applications also of deep learning uses data coming from, let's say, signals or video or, as I mentioned, images. Okay. So this is also a tool that can most of the technology today is being utilized. Now, let's try to understand what is the workflow being used by AI. So there are several key components in the AI workflow, and it's basically composed of the data preparation, the modeling, system design, and finally deployment. So let's try to go to each of these key components. So for the first one, data preparation. Guys, this is very important in building your AI model. The nature of the data that you will be using, uh, because definitely this will influence the performance of your model. Okay? So when we say data preparation, that has something to do with accessing your data. Now, I know you may be familiar with the term big data, okay? And these data are of different forms, okay? Most of them are coming from, let's say, sensors or even files. These files can be in a form of, as I mentioned earlier, images, video, or even signals, okay? Especially when it comes to healthcare, okay? So, yung mga signals from EEG machine, MRI, etc., mga X-rays, okay? Databases, okay? we have a lot of repositories where we get this data. These data are from historical events. Okay, one popular database repository is of course Google database. But aside from that, we also have the Kaggle, and then from the different universities or institutions in the US. Even in China, they also have their own databases, and so on and so forth. So these are data coming from historical events. Okay. So the second component is the modeling itself. So this is where we try to analyze the data. Analyze in the sense that for machine learning, for example, we are trying to see what's the behavior or trend in this given data set. Okay, so where you have this data exploration, and these involves the different approaches such as pre-processing. Okay, so this is also one important component of the AI workflow. In pre-processing, we try to prepare our data and try to look for possible outliers because, for example, sensor data, when you collect data from the sensors which are, let's say, deployed to a particular environment, may wear and tear din kasi yung sensors natin eh. And sometimes, or actually most of the time, we are using wireless communication to transmit the data from sensor to the base station. Now, hindi naman palaging optimum yung transmission. So there are cases na hindi maganda yung transmission, wireless transmission due to interferences or noise. So hindi successfully nakakapag-transmit yung iyong sensor. Another problem is kapag nag-fail yung sensor mo because it's just a device, it's just a hardware device. So pro siya sa wear and tear, and that also affects the data or the amount of data transmitted to your base station or to your server or whatnot. So that actually affects the building of data set. So before you perform modeling, it is very important that you check your raw data and perform pre-processing. So one specific technique is to check some outliers from the data set, or if there are missing data, you have to imputate it. We also do some pruning and normalization, especially if the data is numerical by nature and the values are very variable. So we do normalization to increase the convergence of our data set. And there's a lot more pre-processing techniques that we normally use to again prepare our data set before we do the actual modeling. Okay, and all, as I mentioned earlier, similar to the data preparation, this is also one critical part of achieving a reliable or a good performing model. So ibig sabihin guys, hindi lang po tayo basta okay may data set ako, i-feed ko na siya agad doon sa aking learning model. No, we have to do this component first. Okay? Because this also influences the performance or the capability of the model to be in terms of accuracy. Okay? Now, the next component is the system design. And this is where we already develop our model using the different learning algorithms. Now, how we choose the learning algorithm as also a step or a rule to follow. So dahil napakadami po nating available na learning models, ano, hindi lang po tayo yung basta yung pipili lang na kung anong gusto natin or mag-mini-mini-mini mo po tayo. No? There are rules to follow when it comes to choosing the right model depending on the nature, first, depending on the nature of the data set, and second, on your application or type of application. Okay? So this involves algorithm development and modeling and simulation. So we have a lot of simulation tools available to build our AI model. Of course, we are familiar with Python, okay? So Google Colaboratory, Scikit-learn, PyTorch, okay, TensorFlow, these are all Python-based platforms, simulation platforms. Of course, we do also have MATLAB, Weka. These are, the OG, okay, when it comes to AI modeling and simulations, okay? Some of them are, of course, have a premium, meaning we have to purchase, ano. But of course, if our institution has the campus license, it's advantageous on your end. But if not, we have other, open source, free to use platforms to build our AI. So we have a lot of options on this one. And then finally, the last one would be the deployment. Hindi po tayo nagsa-stop doon sa pag-build ng model. We also, of course, have to deploy it. Okay? Now, there are different devices or platforms where we can deploy our model. Okay? Such as, of course, your network devices, your desktops, or your tablets, or your phones. Okay? Now, a good consideration on this one is that if the device wherein you will deploy your model can actually accommodate the complex task that the model will perform. So there is already this hardware software compatibility. Okay? So, because most of the time, these models tends to be very complex. When I say complex, that there's a lot of computations happening. And of course, your hardware specification should accommodate those complex algorithms. So that's actually the challenge now. I believe in the previous series of this Aora Pulse or nose, we have the edge and cloud computing session, and that actually related to this deployment. Okay, the challenge now is how are we going to deploy this AI algorithms or AI model from the cloud to the edge of the network. Okay, so that is also another, of course, another field of research. Now, included also in the deployment are the enterprise systems and the embedded systems. So embedded systems includes devices that are constrained in terms of memory, functionality, energy. One good example would be our mobile phones. Okay. Another example would be our microprocessors, microcomputers. If you're familiar with Raspberry Pi or Arduino, right now we have already like edge-based microcontroller systems. So most of these microcomputers, microcontrollers such as RPi and Arduino can already implement AI models. Okay, so we have a lot of options when it comes to deployment. Now, let's try to go to the next part of this session, which is machine learning. Again, this is a sub-branch of artificial intelligence. And this particular branch actually teaches computers to do what comes naturally to humans and animals, which is learning from experience. I think it is also the same thing with us human beings. you will notice naman, especially siguro ah, kung meron po ditong mga professionals na may anak na, or maybe may kapatid kayong bata, toddler, you will notice yung mga toddlers, 'di ba? Their minds are like sponge, okay? So kung ano yung nakikita nila sa environment, ini-imitate nila. So they are actually learning from experience. And even kahit sa age natin, kahit matanda na po tayo, we still learn from our experience. Okay? Yung pong decision making natin, hindi naman yan basta lang, pop, ayan na, alam ko na kung ano yung gagawin ko. Yung decision making natin most of the time are based from our experience, right? So it is similar to machine learning. The model or the learning model is trying to look at what's the behavior in the available data set. So it's trying to see a particular trend from that data set, and from that it builds the command that it will use, okay, for or to generate your desired output. Okay, now machine learning algorithms use computational methods to learn information directly from data without relying on a predetermined equation as a model. So this is what I'm trying to say earlier, that the model is not dependent on a particular or predetermined instruction. Okay? So it basically learn from the data set we feed to it, and the behavior of that data set. Okay? Now, the algorithms adaptively improve their performance as the number of samples available for learning increases. So, di ba nga sabi natin uh, mas tama ba yung term ko, mas age tayo, or sige, sabihin na lang po natin mas tumatanda tayo, okay? So yung mas older po sa atin, mas madami silang wisdom. Tama po ba yun? Why? Kasi they are more experienced than the younger ones, 'di ba? It is exactly the same with machine learning. When you feed more data, it actually improves the accuracy performance of your model. So the higher the number of samples, or we call it instances, the better. Okay? So mas madami po tayong i-feed sa kanyang dataset, mas maganda po yung magiging performance ng ating machine learning model. Now, more data, more questions, better answers, especially if these data will be coming from real-world applications. So with the rise in big data, machine learning has become particularly important in solving problems in many, many applications. So basically, we find natural patterns in data that generate insights and help us make better decisions and predictions. Now, we will try to understand this further by of course starting with the machine learning workflow, and then while discussing the workflow, we'll try to use a specific use case, okay, para mas mag-grasp po natin yung idea. Now, before we proceed to the workflow process, let me give to you the different techniques or learning algorithms under the machine learning branch. So in general, we have two learning techniques, which are the supervised learning and the unsupervised learning. Now, when to use supervised learning and when to use unsupervised learning. So for supervised learning, these learning models develop predictive model based on both input and output data. So it means we know what is our desired output label. So sometimes we call it labeled data set. Okay? So for example, we have we want to know what is, or we want to predict what is the value of this real estate property. Okay? So meron po tayong dataset na composed of different real estates based on the size of, or the I mean the lot area, the size of the lot area, and maybe the number of rooms of that house, and then the corresponding price. Okay? If that is the nature of our data set, we call it labeled data set. And we use supervised learning models to build the predictive model out of that data set. Okay? Now, what if ang given lang sa akin is yung number ng bedrooms and yung size ng lot? I don't have the exact figures on the amount of these real estate properties. Then we called it unlabeled data set. It means you only have the input. You don't have the output. So in that case, we use unsupervised learning. Okay? So as I mentioned earlier, there is a specific process on choosing what type of learning algorithm to be used. And one of them is identifying the nature of your data set. If that is unlabeled data set or a labeled data set. So if you have a labeled data set, you use a supervised learning technique. While if you have an unlabeled data set, then you use unsupervised learning. Now, under supervised learning, we have two common techniques. We have the classification and then we have the regression. We further discuss that later on. While for unsupervised learning, we have clustering. Okay? Now, again, as I mentioned, for supervised learning, we use this if we have a label data set. And then there are two commonly used techniques under this branch. We have the classification technique and the regression technique. So when to use classification, when to use regression? Again, we go back to our data set and our desired output. Okay? If our desired output and the given data set is in a form of categorical data, okay? Like for example, if an email is genuine or spam, or if a tumor is cancerous or benign, these are actually categorical in nature. If that's the case, then we use classification techniques. Okay? On the other hand, if our data set is continuous or numerical in nature, like for example, sensor data, temperature, okay, power demand, or even electricity forecasting, these are all represented by numerical values, then we use regression techniques. Okay? No, there are, of course, a lot of different learning algorithms under classification. And then there's also a lot of learning models or learning algorithm under regression. Okay? So again, we have rules to follow when it comes to choosing the right model for your machine learning application. Okay? Now, let's go to the other main category or type, which is unsupervised learning. So there is only one commonly used technique under this type, which is clustering. So because of the unlabeled nature of your data, meaning you don't have an available output label, you only have input. So what this technique does is it tries to cluster common attributes in your data set. Okay? So since you only have features, like for example, the size of the real property and the number of bedrooms, but you don't know the price of that particular real estate. What you do is you try to cluster similar attributes, or you're trying to look at a particular pattern among these lot sizes and number of bedrooms. And from that clustering, you group them, of course, and that will actually build the rules for you that if you have this input features that falls, let's say for example in this cluster, then we predict it as this amount or value. Now if that particular lot or number of bedrooms fall under this cluster, then we predict this at this particular value or price. Okay? So that's how clustering works. Which is, more on like applications on gene sequencing, markets research, and object recognition. Now, again, how do we decide? First things first, you'll try to look at your data set. Okay? That's the first thing to do. After identifying if your data set is labeled or unlabeled, then you go further whether the data set is or has a categorical values or numerical values. So that will fall under classification or regression. Or again, if it is unlabeled or no output available, then it will fall under clustering. So under classification, here are some of the most common learning models. We have the support vector machines, discriminant analysis, naive Bayes, which is based from Bayesian theory or Bayesian inference. Nearest neighbor. For regression, we have linear regression, GLM, SBR, GPR, and some methods, decision trees, neural networks. For clustering, we have the K-means, K-medioids, fuzzy C-means, hierarchical, Gaussian, neural networks, hidden Markov model, and so on and so forth. Again, especially nowadays, there are already a lot of architectures, actually. So we cannot enumerate them all, but at least for machine learning, we have these like commonly used ones, okay? So when do we use machine learning? So first, if we have the following instances like handwritten rules and equations that are too complex, rules of a task are constantly changing. I believe I mentioned this earlier, if you have a very dynamic environment, better to use machine learning. The nature of the data keeps changing and the program needs to adapt. Like for example, in automated trading, energy demand forecasting, and predicting shopping trends. Hindi pa kasi ito nagagawa I don't know if yung mga malalaking retail stores sa atin dyan sa Philippines already employ AI. This is very useful. We have, just to share with you, we have a project before from an undergraduate program wherein we basically try to build a model of the customer behavior in a supermarket. So, because that actually will help the retailers to improve their yung pagposition ng mga products kasi meron din pong meron ding strategy or rule yung pagposition ng mga items dun sa mga stalls when you go to the grocery store, especially yung malalaking supermarket chains. We did try to use detection mechanism for the number or for the what do you call this, the number of customers entering the supermarket, and at the same time we also try to collect the data on the foot traffic and the pattern they are taking doon sa loob ng grocery. That actually help us build the model in predicting the behavior of the customers. Okay? Now, what are the possible challenges when it comes to the use of machine learning? Of course, data comes in all shapes and sizes. As I mentioned to you, this is one important component of your of the AI workflow, the available data set that you have. Second, pre-processing your data might require specialized knowledge and tools. Again, we cannot directly feed the raw data to our model. We have to perform pre-processing to check if there are outliers, if there are missing data points, etc. Okay. Third, it takes time to find the best model to fit the data. They say that machine learning is also a trial and error process. Why? Because at first, when you build the model, hindi agad yan magko-converge and hindi agad natin makukuha yung ating desired accuracy level. Let's say, for example, we want that our model will be able to predict 97, 95%, 98%. Okay? So meaning out of 100 predictions, at least or at the minimum, 95 will be correctly predicted or correctly classified. Okay? Most of the time, hindi agad-agad natin yun na-attain after building the model. So we have to redo the process. So that's why sometimes we also refer to it as a trial and error process. Okay? Sounds doubting, so don't be discouraged. Remember that trial and error is at the core of machine learning. So if one approach or algorithm doesn't work, you simply try another. So that's the good thing naman about it, no? But a systematic workflow will help you off to a smooth start. With that, let's discuss the workflow process. Now, we have some questions to consider before we start. Again, this has something to do with, first, what kind of data are you working with? Second, what insights do you want to get from it, which is your output? And then third, how and where will those insights be applied? So after answering these questions, then that's the time you will now proceed to your workflow process. Okay? So this is now the workflow at a glance. We'll try to use a specific use case on this one, which is a health monitoring app. Okay? I know you're familiar with this one. Kasi most of our mobile phones meron na naka-integrate yan na no, health monitoring app. Siguro yung popular na, you will be the number of steps. Makikita nyo mag-notify lang na lang yan sa inyo na naka 10,000 steps na pala kayo, no? Or even heart rate, etc., etc. Because our phones do have like built-in sensors, gyro, accelerometers, which actually helps it to collect data from based from our activity. Now, going back to our workflow, we first access and load the data. Second, we pre-process the data. Third, derive features using pre-processing, or we also call it feature engineering or feature selection. Fourth, we train the models using the features derived from the previous step. Fifth, iterate to find the best model until, of course, you arrive on your desired accuracy level or performance level. And finally, integrate the best trained model into the production system or simply the deployment. Okay? So let's try to look at each of these components. First, we train a model to classify the physical activity. Okay? So this will actually build our data set. So for example, we have our cell phone or mobile phones with our health monitoring app. And our phones have integrated sensor devices such as accelerometer and gyro. This will basically sense or collect data in our day-to-day activity, like for example, walking, standing, running, or climbing stairs, or even lying down. So we want to use the input data to train a classification model to identify these activities. And since our goal is classification, so we'll try to use a supervised learning. Okay? So again, if it has something to do with categorical data, walking, standing, running, climbing stairs, or lying down, based from the input being provided by the accelerometer and the gyroscope, then we use a classification technique or classification model. So it can be SBM, KNN, naive Bayes, and so on and so forth. So we train the model or classifier will be integrated into our application to help users track their activity levels throughout the day. Okay. So you see now from our input features, which is the accelerometer and gyroscope, we try to predict the corresponding activity, which is, well, can be walking, standing, running, climbing stairs, or lying down. This kind of classification, we call it multi-class because we are classifying several output labels here. The simplest one would be a binary classification wherein you only predict two classes. A good example of that will be your email, either spam or genuine, or like tumor kung siya ba ay benign or malignant. Okay, but this is multi-class because you have more than two classes or output labels to predict or to classify. So the first one, again, is to load our data. So first things first, we have the accelerometer and gyroscope, which performs the following. Sit down holding the phone, log data from the phone, and then we labeled it sitting. Second, stand up holding the phone, and then we log again our data, and then we label it at standing. Third, we repeat the process and collect all the necessary data corresponding to what is the current activity of the person, and we label it properly. So the data set in this case will be in a form of text file. So it can be saved as that text or CSV file using different, like as simple as Excel file, you can use that. Now, the machine learning algorithm aren't smart enough to tell you the difference between the noise and valuable information. These noise can come from like the misuse of your mobile phone, okay? Or maybe the wear possibilities of your accelerometer or gyro, or maybe the data transmission of your sensors. As I mentioned earlier, hindi po laging optimum yung provide ng data or yung pag-collect ng data. So we have to look on these possible instances because this create noise and missing data from our data set. Okay, so that's why we have to clean it first or maybe complete everything or try to fill in possible gaps on our data set. That will be our step 2, which is pre-processing. So if there are outliers, then we have to perform some pruning mechanism or techniques, or if we have some missing data, we want to like imputate our data set. What is important here is we have to make sure that our data set is complete and that it is also normalized. Okay? So in that way, we are sure that those um those implications of having missing data sets or outliers will not make an impact on the performance of our model. So that is why I always tell my students, this is very important step, pre-processing. Building the model using the different learning algorithms or architectures is already like it's an established process na eh. Those architectures are already defined. Those are already established algorithms or established architectures. So we can't do anything about it, okay? But what can influence the model will be this particular step, which is the pre-processing. Okay, so we have to give enough time for this one. This is a tedious process, but through the use of like automation, because we can also automate this process, it will make our lives easier. But we don't we should not skip this one, or we cannot like underestimate this particular process because this is very important. Again, we remove, for example, gravitational effects of accelerometers. As I've mentioned, the data set should be, or the values on our data set should be as much as possible near to one another so that there's an easy convergence. Because there are instances that the values might be very far or very variable from one another. Next step in pre-processing will be the splitting of our data. So we do this because we want to train our model and afterwards test it. Okay? Now, in training the model, we use a separate data set for that. In testing the model, we also have to use a separate data set for that. So before we begin the modeling, once we complete our data set, we now split it into a training data set and testing data set. Sometimes we do the splitting into training, validation, and testing. Okay? We use the normal splitting percentage, which is the 80-20, meaning 80% for the training and 20% for the testing, or sometimes we do the 70-30, 70% for the training, 15% for the validation, and then 15% for the testing. Okay. But the usual thing is that for the training data set, it has to be larger in terms of samples of instances than the validation and than the validation or the testing data set. Okay. So by testing your model against data that wasn't used in the modeling process, you see how it will perform with a known data set. So that is very important, guys. Ano? Yung data set na ginamit natin sa training shouldn't be used for testing. Correct? Because magiging bias kung same data set yung gagamitin mo for training and then for testing. Diba? It will not actually give you a good sight of how your model performs, diba? These two data sets has to be unique from one another. Okay? Third, we derive the features. Okay? This is another important pre-processing. This is a part of pre-processing, you know. Deriving features is also known as feature engineering or feature extraction is one of the important components of the workflow. It turns raw data into information that a machine learning algorithm can actually use. Sometimes because of the huge amount of data and possible input features, hindi lahat yon useful. Okay? Sometimes we have to go to our data set and try to identify which of these features will lead me to a more accurate model. Okay? So there's this technique which is feature selection, wherein we basically identify specific features that will only be used in the modeling stage. Okay? This is also somehow a trial and error process because at first you don't know which features will work, meaning which features will give you the best accuracy model. As I mentioned earlier, it is a trial and error process. Maybe at first you select features A, B, C, D, but after modeling and calculating the accuracy or evaluating the accuracy of the model, it only gave you like 60% accuracy. So what you do? You go back to your data set and try to redo the feature selection, and maybe this time try to select other features. Let's say B, C, D, E, F, and then do the modeling again and then evaluate your model. Then if until such time you achieve your desired accuracy, then that will be your best input features. Okay? So the input or the feature selection actually improve the accuracy of your machine learning algorithm. It also boosts model performance for high dimensional data set, improve model interpretability, and prevent overfitting. Okay? Now, the feature selection also depends on the nature of the data set. Like for example, our data type. We have different types of data like sensor data, image and video, transactional data, and so on and so forth. Now, there's a certain task for selecting the features depending on the data type. Let's say, for example, if you have a sensor data, the feature selection task will be extract signal properties from raw sensors data to create high-level information. For the techniques, it can be peak analysis, pulse and transition metrics, and spectral measurement. We cannot go into each of these techniques, but these are the possible techniques for us to perform feature selection if we have a sensor data set. If we have an image and video data set, what we do is edge location, resolution, or color. Possible techniques would be bag of visual words, histogram of oriented gradients or HOG, minimum eigenvalue algorithm, or edge detection. Now, if we have transactional data, possible feature tasks would be to calculate derived values that enhance the information in the data. Techniques can be time stamping decomposition, aggregate value calculation. So aside from this, there are other techniques that we can use. Again, it depends on the nature of our data set. Now, after we perform pre-processing, and that includes identifying your outliers, imputations, pruning, feature selection, data splitting, this is now the time we implement our learning models to build our classifier or our predictive model. Okay? So we have a lot of learning algorithms or architectures that we can use. In this example, we have the decision tree. So what you see here is the decision tree algorithm wherein it will predict the possible output label. The output label, remember, is our activity or human activity, which can be standing, sitting, walking, running, or dancing. So decision tree, the reason why it's called decision tree, because it's based from identifying weights, okay? And from that weights, it branches out, okay? From the parent node to the child node. So ito yung pinaka-parent node, and then we have here our child nodes. That's from until such time it arrives at the very bottom of your tree. That's the time it can already predict or classify the type of behavioral activity the human is actually performing or doing. Okay? So, aside from decision tree, we have other classification techniques such as SBM, KNN, K nearest neighbor, and so on and so forth. Okay? Now, after building the model, the next thing that we have to do is to evaluate the model. Meaning, we have to see how well it performs. Okay? Gaano ba kaganda yung performance ng model natin? In evaluating our model, we use this particular plot where you can see at the right side of your screens, which is the confusion matrix. Basically, this is a table that compares the classification made by the model. It shows us the true class and the predicted class, meaning we have the expected outcome and the actual outcome. Okay? So, sinasabi niya sa atin basically kung ilan yung correctly predicted at ilan yung incorrectly predicted. Sometimes it is represented in percentage, okay? Sometimes it also represented in terms of the number of samples. Okay? The diagonal here actually corresponds to the accuracy of each of the output label. For example, for the sitting position, we have a 99% accuracy. So meaning out of 100 predictions, 99% or 99 of these samples were correctly classified as sitting. Okay? Similarly, let's say for example, for running, okay? For running, it shows 93%. So meaning, out of 100 predictions, 93 were correctly classified, but there is 7 samples that were incorrectly classified. Okay? For dancing, we have here 59%. So it means out of 100 samples, only 59 predictions were correct. Okay? So medyo mababa yung performance when it comes to classifying dancing. So if you want to improve this one, you have options. First, you can go back to pre-processing and look at your features. Okay? Or maybe there are some issues when it comes to your data set. Okay? So you have to make sure that you have a good and well-prepared data set before you actually build the model. Okay. Now, if you think that you performed all uh, the required task for the pre-processing part, then you may want to another option would be to use maybe another learning model or another learning algorithm. Okay? Maybe for this one, decision tree is not a good option or not a good choice. So that's the time we use another architecture or another model. In this case, we have DKNN or the K nearest neighbor. So after building the model using this algorithm, we generate this confusion matrix. And you will see here that the accuracy level, especially for dancing, increases. Okay? So from 59% from using the decision tree, we were actually able to increase the accuracy level to 92 using KNN. Okay? So this is also one option on how we can improve our machine learning model. So aside from the pre-processing, we may also opt to, use several learning algorithms and try to compare them. Okay, which among these will lead us to the best fit model. Now, if you are not satisfied to 92%, then we may use another model, which is SVM or support vector machine. Now, in using support vector machine, it actually further increase the dancing label, output label, from 92 from using KNN to 96%. So you see how your model evolves its performance from using different learning architectures or learning model. So this is actually a good way to find the best fit model. And again, it will always be a trial and error process. Okay? Now, we further improve our model. This can take two different directions. It might, of course, uh, go towards a more complex model, or it can also be a simpler one. Why we have to consider this? Because remember, we have to deploy it. So it doesn't stop after building the model. We still have to deploy the model, in this example, onto our mobile phones because this is a mobile application. Okay? To simplify everything, we look on the possible opportunities such as feature reduction. Techniques include correlation matrix, PCA or principal component analysis, sequential feature reductions, and there are more other techniques on this one. Then we may also want to look at the model itself, reduce it by performing pruning or removing learners from an ensemble modeling or ensemble learning. Okay? As much as possible, we want that our final model will be in a form that can be accommodated by our embedded device. Most of the time, the deployment happens on our embedded systems, okay? Like constrained devices such as our mobile phones. Now, it can also be on the other end of the spectrum, which is complexity, add complexity. If you want it to more accurate, okay? As mentioned here, can't differentiate dancing from running because it's overgeneralizing. Then we may find ways to make it more fine-tuned, okay? such as use model combinations. This is the method called boosting, okay? Like the ADA boost and gradient boosting, wherein we combine several models. But of course, combining several models will make it more complex, but it will fine-tune your model. It will make it more accurate than using a single one, okay? Add more data sources, meaning you feed more and more data set onto your model so that it will perform well. But again, the trade-off of that would be it will be more complex. Okay. Now, sorry, that already ends our machine learning workflow. The final step would be the deployment, as I've mentioned. So we have to make sure the specification of our hardware device, so that we will be ensured that the model will be running smoothly onto our system. So with that, thank you for listening. And I hope you've learned at least the basic ideas of artificial intelligence and machine learning. So see you on our AORA courses, particularly for the introduction to artificial intelligence. Again, thank you and good morning to everyone. Hello, sir. Sige po.
Alright, sige po. There's
1
a
minute,
quick
sir.
question from Carlo Saul Perez. Is there any tool to play with AI or machine learning?
Yes po. We can use. Sorry. Hello.
Yes, sir.
We can use the open source free to use platforms like scikit-learn, Weka. These are free to use platforms po kasi, no. But if you have like an institutional license, a very good platform would be of course MATLAB, PyTorch, TensorFlow. Kasi mas madaming available na features. But at least scikit-learn, maganda na pong tool yun to begin with.
Okay. Thank you, Sir Mel. Last question for you, Sir Mel. How to determine the system requirements to be able to deploy classification, regression, or clustering algorithms?
Okay. Well, parang ano lang naman po yan. The more complex your learning algorithm, the higher the number of your data set. If you are working with images and mga multidimensional data, those things will influence the requirement of your hardware. Okay? So mas mataas po yung magiging requirement natin sa computational capability. So of course kung meron kang HCP, high computing performing machines or computer, much better. But yung pong ating mga laptops, at least i5, i7, it's enough na po to build complex algorithm. Even yung mga neural network based po, let's say has something to do with images or voice. Okay, kasi mga multidimensional po ito. So medyo mabigat po yung requirement niyan. For those modeling, much better if you also have like a superior processing processor or processing unit onto your computers.